And welcome everybody. Thanks for tuning in to the Daily Space Weather. I'm your host Dan, aka smAsho, and today we're talking about possible sunspot forming, Chinese telescopes, and more. First, we're looking at the sun, the closest star for all you stargazers out there. We're looking at it in 3 different wavelengths of the UV spectrum: 211, 193, and 171 angstroms in red, green, and blue, respectively. And I think we see a sunspot forming down in this area right here. We'll show you more on that later. Some significant filaments here, possibly about to erupt, and lots more in today's Daily Space Weather video. We'll also be talking about our Patreon contest. And let's take a look at some more views of the closest star, stargazers. Here's 304 angstroms, and we see filaments around the north and southeast limbs of the visible disk, the portion visible from Earth at least. And please leave us a comment if you're viewing the videos from another solar system, galaxy, timeline, plane of existence, universe, etc. Here's 171 angstroms all by itself, and you can see some of those filaments in the northeast and southeast. Current sunspot number is at 0, so we may see that uptick today. Here's just the southern hemisphere. And here's the southeast rather. A close-up of this new active region here, possibly about to intensify to the point where it's named as a sunspot. We'll show you the high-res views toward the end of the video. Here's the northern hemisphere. And we see some filaments on the northwestern corner as well, right up here. And we'll show you some close-ups of this filament at the end of the video as well. And here's a diagram of the solar system, and I would warn everybody about reverse werewolves. So the 3 days around the new moon, the day before and the day after the new moon, as well as the day of the new moon, reverse werewolves become a thing. People become less hairy and they sleep in as opposed to staying up all night and eating people. People have also been known to switch to a vegan diet if they're suffering from reverse lycanthropy. Leave us a comment if you suffer from reverse lycanthropy. Anyway, here's where stuff is in the solar system. There's where things will be in a week. And we're only 1 day from a new moon. Next, looking at a star chart, and if you've got a clear horizon and you're up before dawn, you may see Saturn and Jupiter rising ahead of the sun. I guess I got to close that to open that. There we go. There we go. I clicked on it 85 times and it finally popped up. It's Saturn and Jupiter rising ahead of the sun. If you want to make yourself a star chart, check out in-the-sky.org. The radio flux of the 10.7 centimeter variety, which emanates from the upper chromosphere and the lower corona, is at 78, so we see an uptick there. A slight increase in the likelihood that we'll see a sunspot form. And I just wanted to briefly talk about the solar cycle. So you can see this olive-colored line down here is cycle 25, and you can see how similar it is to cycle 24. We saw this early uptick, and then the solar activity sort of flattened out. And now in terms of sunspot number, at least, cycle 25 is almost at the exact same point that cycle 24 was at this point of progression through the cycle. More on that later in the video as well. And here you can see the radio flux and sunspot number, how proportional those indeed are. And that little spike that we were just talking about here And believe it or not, the radial flux made it all the way up to nearly 120 for a brief period. These are the monthly smoothed values. Let's talk volcanoes. Soufrière volcano has caused the island of Saint-Vincent to get evacuated. It produced a 20,000-foot plume of ash yesterday, and there is one of the images of that. You can read more about that on volcanodiscovery.com. Let's see what else has been erupting. Mount Abico producing a 9,000-foot ash plume. So back on the list is Abico, Cinnabung, 10,000-foot ash plume there. Tocono, 7,000-foot ash plume there. Popocatépetl exploding as well. 19,000-foot ash plume there. Revenador exploding. 15,000-foot ash plume. Intermittent emissions from Sabancaya. No idea of the size of the ash plume, if any, there. Soufrière. Continuing eruption, now a 6,000-foot ash plume. Piton de la Fournaise on the island of Réunion. Has announced a new eruption here, a new fissure from the southern flank, about a kilometer from the southern wall of the Summit Depression. And 700 shallow volcanic earthquakes were measured. Magma was rising under the surface, and while making its path, it broke through rocks, generating the quakes. Additionally, the instruments of the Volcano Observatory detected rapid ground deformation in the form of inflation caused by underground pressure and expansion, also indicating that the magma had left a deeper reservoir and was spreading toward the surface. A great reminder to not pole vault the caldera. Please don't pole vault the caldera, folks. It could be unhealthful. This public service message brought to you at great personal risk and expense and liability from smAshomash.com. Today's featured product is the Do Not Pole Vault the Caldera Racerback Tank Top. Pick one up. You can find links at smAshomash.com. Largest earthquake of the past 24 was a 6.0 magnitude at Indonesia. There's a location of that just south of Malang. Not far off the coast there in fairly shallow water. And let's check the rest of the list. That one happened at 7 o'clock Universal Time just this morning on April 10th. So we saw a deep quake in Fiji and another deep quake in Fiji, both over 500 kilometers depth at a 5.2 and 4.2 magnitude. Fiji, basically the deep quake capital of the world. Also a deep quake in Indonesia. .3 struck the Japan region, the southern portion of Japan, it looks like. Vanuatu saw a 5.1. South Shetland Islands saw a 5.5 and a 5.2 at Japan as well. Chile saw a 5.3. Continuing on, back to space weather data. The GOES X-ray flux showing us 0 solar flares over the past 24, and the GOES proton flux showing us 0 proton strikes as well. No surprise there, as the coronal mass ejections that are likely to occur soon have not yet done so. GOES magnetometer looking pretty smooth here over the past 3 days. Earth is solidly in the South Pole current sheet. The heliospheric current sheet is the one we're talking about. And here's a visualization of that. So we can see a little bit of activity here, and you can see the bunched up potential field surface source lines. Let me bring up the latest image. You see these bunched up potential field surface source lines. Those are some of the filaments that we're able to see, and especially those ones there toward the left are highly likely to erupt. And here's some more imagery. It's the line of sight coronal hole plot. And now yesterday, I know we showed these videos, and we showed some older videos as well. Here at the Smash News Network, least busted name in news, we prefer to provide facts. objective ones. And so we're going to look at the line of sight coronal hole plot from 11 years ago. So here's the current state of affairs, and you can see how symmetrical the sun's B field is, which are these blue potential field surface source lines. I mean, we're getting it pulled down a little bit to the south here. Let's take a look at what these looked like 11 years ago. So 2010 on those dates, April 6th through April 10th. Here's what the sun looked like during that run. Look a little different, I'd say. And you can see the coronal holes there starting to migrate over the equator, and transequatorial coronal holes are something that we would expect to see at this point in the solar cycle. However, we don't see it. So here's another view, the line of sight ecliptic plane field plot. Now this is back to current data, folks. So here's what the sun looks like right now, the last 4 days. And here's what it looked like 11 years ago. Look a little differently. And you can see the way the sun's B field is all over the place, stretching all the way from the North Pole down to across the equator and then swirling around to the opposite side. Looks nothing like it currently does. And here's what the line of sight coronal hole plot would have looked like on that same period. So the sun is a little bit behind right now in terms of the progression of solar cycle 25. So here's the detected filaments as reported by the Integrated Space Weather Analysis Center. Like we said earlier in the video, there are quite a few filaments, especially on the eastern portions. Also a little bit in the northwest. The KP index, a measurement of global geomagnetism, is currently at 1. No surprises there. And how about the real-time solar wind? Total background conditions here. Current solar wind speed only 332 kilometers a second. Solar wind density 3.24 protons per cubic centimeter, having made it all the way down to 1.32, maybe even lower than that. Here's 4 hours of Geospace Magnetosphere movies. We're looking at a visualization of the geomagnetic environment around the Earth out to about, I don't know, 15 Earth diameters, approximately the size of the magnetosphere. And it's pretty uneventful here, especially with that low solar wind density and speed. Next, we'll show you ground magnetic perturbations. Geospace delta B, in other words, changes in the Earth's B field, also measured in nanotesla. And we see fairly steady magnetism on the ground level here. Fairly consistent B field perturbations there on planet Earth. Now, we do regularly stream live to Twitch, and we are going to stream live today once again for our meteorology segment. Thanks to our Twitch viewers. If you're viewing on YouTube, leave a comment. Let us know where you like to view the content. Obviously, we are also on YouTube, and most of our content is there. Check our playlists, youtube.com/smashamash/playlists. Thanks to loyal and new subscribers over on YouTube. Cheers. We're also on BitChute. Thanks to our new subscriber over there. And let's do a cosmology segment. Now, today's cosmology segment is going to be kind of short, but there's some interesting stuff to cover here, as always, as there's basically too much stuff to cover for the Smash News Network to handle, which is why we need your help to become full-time so we can do this all day instead of wasting our time doing silly things. So what we're looking at here is a magnetic potential field surface source line diagram of a sunspot system. So this is based on a paper that was recently released here. And here's the paper. This was released on February 25th about magnetic reconnection. And I won't really talk too in depth into this. But if you want to read about it, check out the article. The article that we're going to cite here is from scitechdaily.com, and it's talking about differences in the UV spectrum. So low temperature channels versus high temperature channels at the time of filament eruptions. So perhaps check that out. The article entitled Chinese Solar Telescope Reveals Acceleration of Magnetic Reconnection from a Nearby Filament Eruption. So basically what happened is L2 and L3 interacted with L4. And this might give us some indication of predictive value. So the New Vacuum Solar Telescope, the Chinese 1-meter ground-based solar telescope located in the Fuxian Solar Observatory, is responsible for this imagery, which brings me to our mission. So if you're not familiar with our mission, check it out. smAshomash.com/forum/mission. That's not what I wanted. smAshomash.com/forum/mission is where you can read all about our mission. And one of the reasons why we cover cosmology is because all your weather comes from space. And so, what we're looking for here is to assist mankind by advancing the study of predictive phenomenon in order to optimize value, reduce risk and liability, and save lives and resources, and adapt no matter what the adversity is. If you want to read more about our mission, again, check out smAshomash.com/forum/mission. And let's pick a random number between 1 and 1031. Today's random number is 543, which will coincide with some object at the Neil Gorell Swift Bat X-ray Observatory. 543 is low-mass X-ray binary / massive radio source believed to be a neutron star, QX Nor, otherwise known as H1608-522. I apologize. Here are the X-ray emissions from it, and check it out. It's got a significant cyclicity here. So over the past 16 years, you can see it has this not so consistent cyclicity. And so this is interesting. This is probably something like a white dwarf being orbited by a more massive object. And check it out. We just saw some recent very strong series of outbursts here. A very strong X-ray signal here in the past week, the past like 3 days. A very dense series of X-ray bursts. Let's take a look at it on SIMBAD if we're able to get some visual data on it. So there it is on SIMBAD, and you can see it's not super bright. The location of the crosshair is near this oblong blob of material. So this could indeed be the white dwarf that's being orbited by the more massive object. Keep in mind, folks, X-ray sources don't always show up on this imagery. Let's take a look at some more imagery here. How about the 2MASS, which is infrared light? How about pan-stars, which is the optical spectrum, not showing up there? How about in hydrogen alpha? Nope. How about in red light? And there it is once again in red light. How about on the Chandra? And there is the X-ray source. So great view of that there. How about blue light? And you can see that blob-like object there, which is, I guess, somewhat likely to be the white dwarf component of this low-mass X-ray binary. There it is, an X-ray from the Chandra. You can see a little dim spot there. And that's today's featured cosmology segment, quote, random and quote object, H1608-522, which also could warrant further study, as the cyclicity of this is pretty interesting, at least to me. And that's today's cosmology segment. And by the way, this one was integrated into the Daily Space Weather video. To see the rest of our cosmology segments, check out our playlists on YouTube, youtube.com/smAshomash/playlists. This one is nested inside today's daily space weather video. So continuing on here, here's the electron flux, and we're seeing surprisingly low levels of electron flux. This is the one-year chart as reported by Solon.info. Here's a 3-day chart, and you can see how low the electron flux has been here over the past 3 days. And here's the forecast model, and we are expecting an uptick here in the in the electron forecast. I mean, I would say I'm forecasting up there for tomorrow, as we're seeing these surprisingly low levels of electron flux. Anyway, the green boxes are the forecast, the yellow diamonds are the observation. Here's a diagram of the Van Allen belts, and we show this daily to give people a visualization of what we're looking at, since we're in the realm of electrons now. And here's the total electron content forecast, which is basically a visualization of the entire air column from where your GPS satellite's located down to your handset. And once again, with these low levels of electron flux, we see some anomalies here at nighttime, some surprisingly high levels of GPS error likely around the equator, especially north of it around midnight indeed. You can see here at nighttime some anomalies over Central Africa, the Central Atlantic, etc. And it's typical of low levels of electron flux. And here's another diagram of the atmosphere. We show it daily to give people an idea of where things are located. That red F over there on the right is the F ionosphere layer, which is now what you're looking at, a visualization of that. Around 300 kilometers of altitude, the F ionosphere layer is shown here by the Australian government, a Bureau of Meteorology, in megahertz. So vibrational frequency in terms of millions of vibrations per second. Ionosphere looking less anomalous here than it has in the past few days. Some less extreme rapid charge ups and charge downs happening, especially over the Atlantic Ocean there. And what you're looking at here is one full day of the ionosphere. Each tick here is 15 minutes of time elapsed. Some charge downs over the Pacific. A little bit of a wobble going on there in the ionosphere. Not really that surprising, especially with these low levels of electron flux. Here's the latest image coming in at 9 o'clock Universal Time. Next, we're going to talk some meteorology stuff. But before we do that, let's welcome our viewers from Twitch. Welcome, viewers from Twitch. We're doing a meteorology segment here, which is integrated into today's daily space weather video. First thing we're looking at is the jet stream. Here are the jet streams of the eastern world, and I would note they're blowing backwards over the western Pacific and over Indonesia. As well as the easternmost portions of the Indian Ocean. Here are the jet streams of the western world. Quite chaotic here over the U.S. They're like tripled up here over the Great Lakes region. You can see 3 jet streams here, one there, and one there, and they're all separated, creating some massive pressure gradients, I would assume. Here are surface winds. And you can see 2 powerful low pressure systems there in the North Atlantic, as well as this low pressure ridge right here, just off of Newfoundland. And here are the surface winds of the eastern world. Next, looking at the Doppler radar. And just give that a minute. There we go. There's the global radar scenario. I'll move that around so we can see Eastern Europe. There we go. And we see some very strong storms in the southern portion of the U.S. once again, west of the Florida Panhandle. Keep in mind, folks, in the northern hemisphere, the northwestern corner of a severe thunderstorm is the most likely place to see a tornado. Southern Alabama is getting pummeled right now. And those storms are moving east-northeast. More on that momentarily. First, lightningmaps.org. It's where I go for real-time lightning maps when I hear thunder. And check it out. Some very, very active cells there just west of Montgomery. Hey, Montgomery, you're in the crosshairs. Mobile, there's thunder rolling in. Yowzers. Serious lightning happening right now. And if you're within a few dozen kilometers of these storms, go take a look at them. Look at the cloud tops. Take some time-lapse photography. You may photograph things you were not expecting. Things like sprites and green elves and green clovers and blue diamonds and pink horseshoes. And here's a U.S. Doppler radar map, and check it out. Some extreme weather there, coating the entire state of Mississippi. Also some strong storms hitting Louisiana, Arkansas, Missouri, and Alabama, soon to move into Georgia, Tennessee, North Carolina, Kentucky, West Virginia, and Indiana. Later today into Virginia, and so on. Here's a better idea of the storm track. By looking at the cloud layer, it's too dark to see the clouds with a visible satellite. We use the 3.9 nanometer NASA GOES shortwave radiation map. And here's the water vapor to give you an even better idea. And you can see that moisture is getting a push from this dry mass of air driven by the jet stream in this sort of a fashion. There is another low up here, which is slowing down the movement of that. And for you new viewers, realize that this dry air here is more massive than this moist air here. Yes, I know, it's true, folks. It sounds crazy, but it turns out that the molecular mass of nitrogen is higher than the molecular mass of water vapor in the atmosphere. And that's a quick meteorology lesson for you. And let's zoom in here. Since it's so extreme, we're going to zoom in on the tip of Louisiana here, just the tip. And we'll show you close-ups of those scenarios in both cloud and in water vapor. Let me shrink it down. There we go. Some extreme weather striking there. We may have to make another video about this. Cloud layer, water vapor. And check out the sudden cloud nucleation right here in the Gulf. It's a bunch of hot water and hot air mixing together to evaporate water. It's not because of Nibiru, and it's not man-made. And that's today's meteorology segment. I'm going to have to say goodbye to Twitch. Bye, Twitch. And let's continue on for the daily space weather. Some latest images in hydrogen alpha. How about from Udaipur, India? And here are the newest images from that. Again, you can see these filaments. Really, all four corners of the sun now have filaments. The likelihood of a coronal mass ejection is very high. I'd say greater than 90% right now, folks. And I'd like to welcome everybody to the Neo Renaissance. Check out our own website, smashamash.org, smashamash.com. Click our links, support our channel, become a patron, etc. Check out the forum, smashamash.com/forum. Perhaps enter our April Slam Poetry Contest and win a free month of Patreon for May at the $3 per month level. Thanks, Smash Team. Thanks most of all to our patrons. We've updated our credit crawl. Please consider becoming a patron at patreon.com/smashomash. Patreon.com/smashomash, the true source of funding for the content. as our subscriber count stagnates seemingly forever on YouTube. Thanks again to our patrons. Here come bonus features in the form of a high-resolution colorized magnetogram showing you this new sunspot, which is actually showing some umbra, although weak. Here it is. And it's degraded since I did show prep, folks, so there it is. No umbra. Although I think a sunspot is forming there with the uptick in the radial flux as well as these magnetogram images. We'll keep you posted on it. If we see some more activity kicking up throughout the day, we'll put up another video. Here's a full disk view in 193 angstroms. One of the ionized states of iron. And here's a close-up of the southeastern limb. That new active region. And here's a close-up of the northern hemisphere in 304 angstroms. Thanks again for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, and may that solar wind be at your back.